Hey guys, Professor Doney back here. We are talking about momentum and collisions specifically. And this time we're continuing, that's continued, to look at bounce. Problems where the objects bounce. We did one earlier. It's now on YouTube for when they stick together. This is when they bounce. Okay, so we're going to have these two objects. I'm just going to draw them as circles. Let's say this velocity is coming in at 10 meters per second. Let's say the velocity of this one is just sitting still to make it easier. And afterwards they both have a final velocity. I'll call it v final 1 and v final 2. We don't know what either of those are. So we have to find out there. So let's give them a mass, I don't know, 2 kilograms, 1 kilogram. And just for, again, easy numbers. Now we have two unknowns here, so we're going to need two equations. The first equation, which we always go to for collisions, or most of the time, is the momentum, conservation momentum. Initial momentum equals final. So we have to look at the MVs before, we sum the MVs before, and we sum the MVs after have to equal. So on the left side, the before will be 2 kilograms times 10 meters per second plus 1 kilogram times, what is that, 0? And actually I'm going to change that to a 4 just to do something a little different, having a smaller object hit a bigger object. In the previous example we had a bigger object hit a smaller one, a bigger car, smaller car. So we'll just switch it up here. I'll make that a 4. Hopefully that'll be easy to correct in your notes. On this side, what do we have? 2 times v final 1 and 4 times v final 2. Now we can clean this a little bit up. Clean this up a little bit. That becomes a 20. That becomes a 2 v final 1 plus 4 v final 2. And I can go there and actually clean up even further by dividing out by 2. That'll become a 10. That becomes a v final 1, and that becomes a 2 v final 2. Okay, now two unknowns there. That becomes our equation 1 that we cannot continue with till we get a second equation. Now what is the second equation we're going to use? Well, it comes from energy, and you can look at a textbook, and it starts out with looking at kinetic energy, conservation kinetic energy, or total energy, and they come up with an equation that basically says the difference in the final velocities equals the negative difference or change in the initial velocities. If we write that out, it's going to be v2 final minus v1 final equals the negative of v2 initial minus v1 initial. Now if you want to see how they do that in the book, knock yourself out. It's not very exciting reading, but you can see where we get that equation. So this is our second equation that we're going to use to help solve, because we have two unknowns there. So let me just change colors. I'm really enjoying doing this. v2 final, don't know. v1 final, still don't know. What equals negative v2 initial? v2 initial was 0, and v1 initial was 10. Now right here, this negative sign is usually the biggest mistake students make. They forget to put that through. Now there's a 0 there, it doesn't make a difference, but this side is going to be really negative 0 minus 10, minus and minus 10, which gives me a plus 10. So be very careful when you have this side, because that's where we see a lot of mistakes. Alright, so real quickly, I want to substitute this equation back into this one. What I'm going to do is solve for v final 1, or v1 final. v final 1 is going to equal v final 2 minus 10, and then I'm going to kick that in right there. And the reason I solve for that is because it has a 1 as a coefficient. I don't have to multiply it by anything. So real quickly, this equation becomes 10. I sub in what I just had, v final 2 minus 10 plus 2 v final 2. Going to add them to the side. I get 20 equals 3 v final 2. That tells me that v final 2 is 3 over 20, which is 6.7 meters per second. And then v final 1 from any of these equations with 12, we have 667 in there, is going to be actually